Hi, okay, so today I want to show you how to set up a pipeline in DeVIDE FE Measure so that you can go from volume description of your data to finite element analysis conformal volume mesh. So first we insert the data. In the next step we use a configuration module where we set up a working directory so that all the data that are generated are stored in this folder, and we execute the network. Then so then we see all the labels that are there and all the labels that we use. We want to use all of the labels, so that's fine, but here you can make a selection. And now we choose a color table for each of the labels. So label 0 is normally the surrounding. That's why we just use a black color for it. The first label in these data, so it's a femur data set, is some kind of empty void. So this will be that. The label number 2, that is some damaged tissue, so we will label it like that. Number 3 is let me have a look. Yeah, that's the spongy bone. Number 4 is the outer bone. Number 5 is the cement from the cement injection, and label number 6 is the implant. So after we set up all the colors for the color table, obviously it demands that you know which kind of label corresponds to which kind of object. We're basically done with this step. In the next step we use a tightening algorithm. And use this curvature. Afterwards, we need to binarize the label, distance field that is coming out of it, for which we use the multi-binarizer. That gives us the crossings between all the labels, and it gives us, of course, the binary image. Then we use a medial axis transform for the later steps of the meshing, which we connect to the tightening, and we set a corresponding gamma value. Afterwards, we need to generate a new sizing field that corresponds to the medial axis and the local feature size that comes out of this process. But first we need to generate so the output from the multimedial axis transform is a volume image, but of course we need to generate a point cloud out of this. For this we have the multi-binary image to point cloud. So now we can connect the point set to the medial axis points. Then we need our initial data, our image data, and we need the boundary, for which we have this. So in the next step we generate a crossing. So basically out of the crossing image we generate points that are used as seeds for the particle simulation. Which is exactly our next step. So you can see here you need the seed dictionary, and the seed dictionary comes from there. Then we again need our image data, and we need the sizing field. What you need is always displayed here in the bottom left corner. So after we have the particle system, and after the particle system distributed all the data, we can generate a boundary mesh. For which we use the full particle cloud. And again, the image data. And of course, from the boundary from the surface meshes of each object, we can generate a volume mesh, multi-volume mesh. Which demands the partial surfaces, and what comes out of it is either like the full volume. So all objects together in one container, or each volume separate, or these things again as unstructured grid, so that you can use them, for example, in ParaView for visualization. But of course we can also visualize them in this software with the multi-volume mesh viewer. So after we have set up the whole pipeline, we can just store the network. And we are ready to run the full network, which will take now several hours to complete, depending on the data that you have.